Hello everyone. My name is Vinicius, and for the next minutes, I'll be talking about how my research tried to bridge embodied interaction and the emerging field of data physicalization, which is a good starting point for us to talk about the context and motivation behind this thesis. Well, physically representing data is not something new. Ancient civilizations have been doing this for thousands of years, and in this example, it was likely to support the act of counting. And it's fun to see how the same or very similar information encoding is still used in today's artwork. Both of these examples were extracted from dataphys.org, which is the most prominent catalog for data physicalizations. And it's possible to see that passive or static data physicalizations are much more numerous than interactive or active data physicalizations. So the ones that change or that behave differently according to user interaction. One example of interactive data phys is wage islands. So you have this topographic map of New York City that gets submerged into this water, very dark water, to reveal areas in which it's easier or harder for people to afford. So by tapping a button that is attached to this aquarium, so to speak, users can change the hourly wage they want to represent, and the physicalization will change the water level to reveal more or less areas of this map. So it's basically filtering out data physically to reveal areas that are how people are constrained to specific areas of the city depending on how much they earn. And what I liked about this project is that it perfectly fits the definition of data physicalization, because even though if there were no interaction, the map itself is still considered a data physicalization because the shape of that map encodes data. However, a different way of relating interaction and data-driven objects is this project. It has a completely different interaction modality. So the solar radiation dowsing rod was created for a space observatory. And as you pick up this piece of wood and you point it to the sky at different directions, you can feel through light and sound and vibration the amount of solar radiation coming from that direction. So what I think is relevant about this, and that deeply inspired me, is that the shape of this object is kind of meaningless. It does not encode data in itself, but rather data can only be perceived during the interaction. And here we can see a child having a lot of fun while doing so. All the things that I talked so far led me to focus my research area in between embodied interaction and information visualization. And I know that I'm above the information visualization here, but believe me that beneath me, it's written information visualization. So this is where I chose to focus on. But in order to have something very concrete by the end of my research, I chose a very specific application area: in-person visits to an Earth Sciences Museum. And I chose the Geosciences Museum of University of São Paulo as a case study, but my results could be used by other venues, other similar museums in the world. This venue was closed due to the pandemic, but I have been there prior to the pandemic twice in my life, and it's a place that I really enjoy. And that was one reason for me to choose it. The other reason was that the museum has demonstrated its interest in making things tangible So at the entrance, you could see this huge dinosaur skeleton, but you can touch it. But inside the museum, the skull of that dinosaur is available for visitors to explore, to look around, to touch, to feel how sharp the teeth was, things like that. And a similar approach can be seen at the touch table. So after a mediator, for example, explains different minerals and fossils to a group of students, they are invited to go to the table and explore and feel and really grab with their hands these minerals to kind of explore them. They also have tools like magnifiers to help in such exploration. Well, all of this that I mentioned was phrased as the following research question: how embodied interaction might influence earth sciences learning for museum visitors through data physicalization. In order for us to answer this, it's important to first define what I mean by embodied. And embodiment regarding the data phys realm has a very specific meaning. So it's typically used when the data is conveyed through the use of a metaphor that is connected to what the data depicts. So if I'm, for example, showcasing data that is related to, I don't know, the amount of rain in a specific region, instead of me using like physical bars, I could use something that was using water or something like that. It has to be some kind of a little bit closer to the meaning behind the data and not be too abstract. But regarding the interaction aspect, I'm using embodied as something that exploits the fact that the interaction is happening in a real world, in a real environment, and that uses whole body movement, things like this. Well, I chose to pursue this research by using mainly two methods. The first one is research through design. And what I mean by this is that I don't plan on creating a definite solution or a framework. Instead, I'm trying to create an artifact that is conceptually rich, that represents an idea. And I also heavily relied on interviews. I interviewed both specialists as well as 3 anonymous user testers that tested the prototype in the end. Regarding the specialist, I began my project by interviewing 3 people. First one was Arielle, which is a mediator at the Geosciences Museum. She works there as an intern, but she has a lot of experience in conducting user visits. I have also talked to Julia, who is a data visualization researcher and teacher who has conducted data physicalization workshops with children, for example. And I also talked with Fernanda, who teaches at a primary school. And in order for me to kind of get a little bit more familiar with the pedagogical benefits of physicalizing data, for example, I was able to condense those interviews into what I called pedagogic principles that my project should try to address. There are 5 of them, but they're in no particular order. The first one is that my project should ignite children's curiosity through exploration. It should associate a new concept with a day-to-day or personal reference. So in order to introduce something new, I should kind of try to connect that with something that is already familiar to the people that I'm talking to. Number 3 is that I should encourage social interaction. So encourage discussion, encourage people to exchange their strategies or experiences while dealing with something. Number 4 is that we should not just answer questions. So, for example, if I'm mediating something, if someone asks me something, maybe I should not answer that as like if I know everything, but I should instigate people into formulating questions on their own, into formulating such hypotheses. And number 5 is more related to the Geosciences Museum. So both Ariely and Fernanda mentioned that they usually try to guide children into locating and situating themselves geographically. So really thinking, okay, where am I in the world right now? Am I beneath the equator? Am I like really thinking about their surroundings and reflecting on that? Both of them try to kick off their classes or the visitors with such approach. And based on those pedagogic principles, I began generating and evaluating some ideas. There were like a few, I don't know, dozen, but I chose 3 to present here. One of the ideas that I found promising was called the dinosaur racetrack. So it would be a real scale racetrack that prompt visitors with the question, how far can you get in 2 seconds? Could you outrun a T-Rex? So people would start running and they would have to stop after a specific number of seconds. And as they stopped, as they froze in that position, they could look on the ground and see this giant at-scale footprints of dinosaur species. So there could be a T-Rex or raptors or any kind of species, and they could see, oh, the ones that are behind me are dinosaurs that I could have outrun if I was running away from them. And the ones above me, well, that's a different story. But I could also have, I don't know, maybe Usain Bolt here for reference. But yeah, even though I really enjoyed this idea, and people might benefit from having a digital timer for go and stop signs, this interaction would be kind of trivial, as most effort would be related to data collection and information visualization. So I chose not to pursue this, as I would not focus on the interaction or on the data physicalization aspect of it. The second idea that I brought here is the magnifier one. If you remember the touch table that I mentioned earlier, where people could explore minerals with magnifiers, what if we could hack some of those magnifiers with color sensors that could turn the color and the texture of that mineral, of those minerals, into sound, some kind of sound that could be played to the whole room. So maybe it could allow for some creative expression, some games. Could be a fun experience in exploring the physical properties of those minerals. But even though it could be good, I am not familiar with audio manipulation, so I thought it could be too risky to pursue this path as my thesis. So I decided not to do that. And what I did, in fact, decide to pursue was the magic shovel idea. It basically is driven by the question, where in the world would you end up if you were to dig a hole in a certain direction? So by equipping a shovel with motion sensors, and by knowing where people are using the shovel in the world, we could use computation to simulate a hole through Earth and communicate that person that, oh, if you're digging a hole towards this direction, you'd reach China or India or Australia or the US, for example. And this is what I chose to pursue. I thought that users could benefit from situating themselves geographically, that this could be to help them achieve that. They could maybe get a sense of Earth's magnitudes in doing so. So like with this slight movement of angle in the shovel, I could reach a different country. I mean, that gives you an embodied sense of how big Earth is. And they could also benefit largely from discussing Like, why has nobody ever built this tunnel? Has someone tried? How would gravity behave inside this tunnel? Is it different if you're going like from the equator to the other side of the equator, or through the poles? Or why is it impossible? What would you have to go to dig through? Like, what are the inner layers of Earth? And how hard would it be to dig through that, if it's even possible? So I think it's really a conversation starter, and I think it could hugely address those pedagogic principles that I mentioned earlier. So it was a go for this idea. I consider this sketch to be the first iteration of that idea, in which I represented human figures at scale with a shovel, in order for me to see like how big a shovel could be to address both children, and here we have 9-year-olds as well as adults handling it. And on the first picture here on the left, you could see a direction that would be pointing to Japan, or to an ocean, or to Canada, things like that. Well, and I ran this sketch through the 3 people that I had previously interviewed, and feedback was generally good. And here I highlighted some aspects of it. Ariely mentioned that it could provide a sense of scale regarding Earth's magnitude, so that was a good thing. Julia mentioned that one issue might be that subtle changes in inclination of the shovel might point to a whole different country, and that might be might fluctuate a lot and be an issue. But Fernanda mentioned that even though this idea is really connected to children's curiosity, it could also engage adults. And this led me to reevaluate who my target users were. So I began focusing on children. I thought it could be fun for them, etc. But I also realized that even like checking related work, I thought that adults were equally or even more interested in this topic from this kind of more technical standpoint also. And since I would have easier access to adults for user testing, I chose to focus on them. Well, in order for me to create this simulation, I began prototyping with an Arduino board, which is an electronic component. The idea is that this electronic component would control a virtual tunnel. And what you're seeing here is some of the tests that I experimented with while creating this tunnel. So I tried to visualize Earth's mantle and core in very different ways, but in the end I chose to visualize something simpler first, to remove visual clutter. And this was an early experiment of using an Arduino board with motion sensors, sending that orientation data to the computer through cable to help animate this tunnel that is running on the browser with JavaScript using a library called 3JS. The idea is that this Arduino could be attached to the shovel along with a battery, and this would send data to an external computer, maybe through Bluetooth, so there wouldn't be any wires involved. It would send the angles and where am I in the world to the computer, which would run the simulation and communicate back to the user where would I end up and how far that destination is from me. In other words, how lengthy would be the tunnel towards that destination. In order to communicate that, I experimented with visual feedback. So in this example, we have a shovel that presents this wavy animation if the user was pointing to an ocean, and this downwards arrow animation if the user was pointing to land. But I also have an auditory experiment. It's very early on, but the first one is as follows. So what you saw here was like this noise that would accompany the visual. And while experimenting with that, I really felt that with sound, the whole experience felt more believable. It really felt like the shovel was actually a tool that was kind of this country detector. It was like this whole complete thing working on its own. And in order for people to get rid of that noise, that static noise on the background, they would have to point to a country, because then the 2 beeps would come in and kind of silence would be the indicator of, hey, you found it. And in this other example, I tried something a bit different. It's also related to sound, but what if I could be pointing the shovel, and if I'm pointing towards an ocean, I could hear this ocean waves, and if I am pointing to land, I would hear people chattering in different languages maybe. So it was like the shovel would allow me to hear what was happening on the other side of the world. Maybe the shovel was not going to be like the best metaphor for this, but it was an experiment. Great, thank you. Now back to the presentation. The issue with Arduino is that I ran into several technical issues. The readings that I was getting from the motion sensors were not precise enough, and I couldn't get it to work without wires connecting it to a computer. So in order to move on and create an actual prototype, I chose to use a phone instead. So the idea is that I would use a phone and read the sensors from that phone. So I would read the angles, the direction it was pointing to. I could read the geographic coordinates of it, so by using its GPS. And I could also use its digital compass that is already built in, and it's easier to get like this absolute orientation point of reference. So this that you're seeing here was an early experiment. It's by no means a final user interface, but it was just for debugging. But it was really promising. So I moved on into refining this globe. And what you're seeing here is what the final globe on the prototype looks like. So it's basically this wireframe globe with nothing inside, where you can see like the back of all countries as well as the front. And you can see this red line representing the tunnel. So right here, where my picture is currently above, you can see the origin, which is currently on Santiago, Chile, and a tunnel straight down that location will lead you to China, which is the destination. So, and I also add the stars in the background for reference. As this on the website is a moving thing, you can see it helps people perceive the rotation better with the stars. All right. So in order to move on with this, I had to attach the phone to the shovel in a perfectly perpendicular way. Otherwise, calculations would be kind of messy. So that's what I did on the last iteration. I was able to attach this phone holder to the shovel, and what would be playing on screen would be something like this. So here we don't see the globe. The globe is hidden for people to focus on the country. So as soon as they reach a country, that country is highlighted, and the name of the country is displayed on the middle of the screen. And this red thing here in the middle represents the tunnel. So it moves according to the movements of the device. for people to get this feeling that it's working, it's behaving as I move it. And on the bottom, we have some helpers. We have a compass and also a numerical length of the tunnel towards that angle. And of course, I call this software the Super Tunnel Simulator, which would be running inside an electronic device attached to the shovel for it to be more tangible. This is what it would look like from a first-person perspective. So here you can see that even with small movements, very subtle movements on the shovel, the tunnel would point to a whole different country. So from Japan to South Korea to Russia. And this is what a bystander, another visitor, a third-party perspective would look like. So whenever someone's interacting with the shovel, they would be seeing something, but the same thing would be, the same simulation would be kind of displayed to the whole, to other visitors in the museum. And the idea behind this is to foster communication and interaction between people. So I could be pointing, I could say, oh, try to reach Sweden. Oh, try to reach the US. Oh, I bet you can't reach Cuba using this because Cuba is such this tiny island, which would be very hard to point towards, or Hawaii even, which is even harder. So there could be also like some guidelines on the floor indicating, for example, the north direction for people to have some point of reference. And people could say, oh, try pointing west a bit. This kind of interaction between people. I unfortunately was not able to test the shovel with other people. I was the only one, me and my fiance, of course, but we were the only ones that tested the shovel. But I did invite 3 participants to experiment with the software itself. So on their own phones, they tested the prototype, and I got some learnings out of that. But before that, there are, of course, some limitations. First 2 are related to imprecise data. And since the Geosciences Museum was closed during this research, no in-person tests were conducted. So this was not tested in a museum scenario, obviously. Even though I talked to a few people, like interviewed specialists and also user tested the prototype, findings from that are not to be generalized, as these participants were chosen by convenience as well as in small number. And since the final design is still heavily visual, users tend to focus on the screen and not on their moves. And I believe this is the biggest downside of this project, is that it aims to be a data physicalization and interactive one, but the output to the user is still heavily visual, like a data visualization, a traditional one. I think this is due to my own bias into creating data visualizations for a lot of years. I kind of went with what was easier and more natural and for me, but I could have tried to experiment more with other ways of communicating. Let me give you an example. One of the people that used the phone prototype on their own phone and record the screen while doing so, this person reported that it was hard to know where to point to. And by the way, this person said that it really felt like they were really using the movements of their body as a way to control what was happening on screen, and not really reflecting on where should I point to, not really reflecting on their moves. Christina Hook, which is a prominent researcher on embodied interaction, has had a similar problem, and her team addressed that by using sound instead of visuals, and sound really entice people to focus on that inner experience. So that might be, looking back, it might have been better for me to focus on sound maybe, or even not representing the globe physically to the person, but really just printing out the names of the countries. That could be better, because there would be no way to control that red line on the screen, but that could have helped people to focus on their movements instead. And there are, of course, some learnings regarding the embodiment aspect of the project. Again, this is my personal perspective on this. I have really reflected and played with the shovel, and I think that there are some kinds of things that you get for free when you use this kind of tangible and embodied interaction. First one is that simulating a tunnel straight down is easier. I mean, due to gravity, pulling the shovel downwards, simulating a tunnel straight down, that is to simulate the exact antipode of a point on Earth, is easier. You just need to kind of hold the shovel loosely by its handle. The other one is related to something that Julia brought up in an interview, in a feedback session. She said that maybe subtle movements would highly impact the simulation, which is true, but I think that effect is minimized by handling the shovel and not the phone directly, as like bigger movements on the shovel translate to smaller movements on the phone due to this lever effect. And one of the insights that I also got from user testing, regarding the prototype. Remember, people did not play with the shovel. They really only played with the software on their phones by moving their phones. And I asked people to record their screens, and I could analyze that a lot of people were putting their phones upwards, so not really pointing downwards towards like the center of the Earth. And that led me to do two things. First, on the software, I created this alert, maybe trying pointing your phone to the ground or something like that. But I think that behavior would be minimized if people were using the shovel, because since the shovel itself embodies the digging metaphor, and digging means pointing this to the ground and sinking that in, I think this pointing the shovel to the sky kind of feels unnatural. So I would argue that that would be one benefit of embodiment. Regarding the research question itself, there were also some findings. So I learned that embodied interaction might influence learning, not by teaching content, not by saying, oh, this is how big Earth is. These are the layers of Earth. This is what they're made of. Not by teaching explicitly this kind of content, but rather by igniting people's own curiosity and stimulating people to formulate their own questions, stimulating hypotheses. I think that's a very important contribution, and I think this is also in line with what, for example, the engagement approach of the Science Museum group, for example, which uses igniting curiosity as their a very important aspect of the experiences they create there. And on a broader sense, I think there's an interesting contribution regarding the interaction aspect of this project. So when we're talking about interactive data physicalizations, as I mentioned earlier with the Wage Islands map, that project conveys data through its shape. But I think that this project tries to convey data again only during interaction. So if you see this shovel and it's just sitting there, it's just a shovel. But as you pick this up and you begin interacting with it, then you can perceive it as a tunnel simulator. And I think this is a very different way of experiencing data phys. I think it's really relevant to further explore that. And on that note, there's a lot of things that would be relevant to explore. The first one would be to conduct user tests in a real museum situation. For example, to actually see if and how those social interactions occur around the artifact. It could also be relevant to experiment with embedded or invisible technology. So not just attaching a phone to something, but really creating something that makes it feel like the shovel is magical, or the shovel is this complete single object, and not like two things attached like the phone thing. And it could be also relevant to explore other senses. As I have mentioned, audio could be relevant to help people focus on their inner movements, their inner experience, and reflect on their position and where they're pointing to. It could also improve accessibility. Right now with this prototype, if you're not seeing what's happening on screen, then you're not able to get anything out of this interaction. It could also be interesting to understand how the environment affects the user's perception. So if it is a shovel and a shovel is deeply connected to the ground, is it different for people to use this shovel like above grass, or on ground level, or on the high floor of a building, like on the top of a building? Is it different? Does one makes it easier or harder to understand? Could be interesting. But again, on a broader sense, I think there's much room to explore the intersection of tangible and embodied interaction and data physicalization. And again, specifically exploring how an artifact can convey data not through its shape, but only through our interaction with it. This is what I try to do here. And as a bonus, you can play with it even though you don't have a shovel at hand. The prototype is live at supertunnel.app, and you can, on the desktop, you have this red dot here that you can drag around to simulate a tunnel towards different angles. But on the mobile phone, you can use the exact same prototype, same version of the software that was used on the shovel. So you can move your phone towards different angles to simulate a tunnel towards that.